Hello, everyone, and sorry for starting late. I had to change the event URL, but we will be live in a few minutes. Okay, let's get started. Sorry once again, we're starting late, but we will rush through this. So, today I want to talk about machine learning, but from a completely different perspective. And that perspective is that of the data analyst. And what that means is that this is an individual who spends most of their time working on databases, um, and they write SQL. So it could be PostgreSQL, it could be MySQL that they're coming from, even Microsoft SQL Server. Now, the first thing we should talk about is the difference between an analytics database and a transactional database, because this is the perspective of analytics. So for me personally, I started out working on transactional databases. Um, so I encountered MySQL pretty early on in my journey as a software engineer. And I spent a lot of time working on it. It was only a few years later that I encountered Microsoft SQL Server. Now, most of these databases are set up such that your application connects directly to them and it writes to them and updates them frequently, depending on how many users you have. It could be every minute that these database tables get updated, and they're also getting read from. So just to think about it, if you have like an e-commerce website, then you're going to have the front end, which is where people go and they view the catalog and they add things to checkout. But at the back end, you're going to have the database that actually hosts the items. And every time someone is on the website, that website is reading from the database. And every time a purchase is made, that website writes to the database. You could even have advanced situation in which every time the users change pages, you're tracking what page they're on, what they are looking at, how long they're spending on that site. So that's one situation, but we're not going to go into analytics for e-commerce. Instead, we're going to go look at a different type of situation. So that database that backs your application is an sorry about that. There's it. I need to let someone else in. Just a second, please. So that database is a transactional database. It gets updated, it gets read. You don't want to carry out analytics on that database. If you carry out analytics on a transactional database, it's going to slow down considerably. People are going to be wondering why your website is so slow, but it's not the website, it's a database that backs it. So instead, we usually have analytics databases, and data is transferred from the transactional database to the analytics database. And it is that analytics database that is inspected. And that is where you go to ask questions about what exactly happened in the past. Now, with machine learning, what you try to do is to make an inference as to what could happen in the future. And one such database is BigQuery. BigQuery is a fully managed analytics database from Google, and it lets you run all the queries. It scales up to meet the needs of your data and your query. So things usually execute quickly. Now, in this session, we're going to go take a look at BigQuery. We're going to take a look at the BigQuery database itself on the Google Cloud Platform. And then we're going to look at its machine learning capabilities. So remember, as an analyst, sometimes what you want to do is look backwards. Sometimes what you want to do is use the information from looking backwards to look forwards. So without spending too much time, I'm going to go and I'll be using a platform called Cloud Skills Boost for this, and it's just an interface to the Google Cloud Platform. So you can go directly to Google Cloud Platform and do everything that I'm doing. The only difference is that with Cloud Skills Boost, I don't get charged the normal charge for using GCP. And I'll explain all that in BigQuery as I get started. So just a second while I launch an instance, and then I will share that. So if you do not already, you can go to cloud.google.com and create an account, and you'll have some free credits. BigQuery itself provides a free tier that lets you play around with things and get used to them. Okay. Okay, so this is what you get when you have a new project on the Google Cloud Platform. And I will just jump straight to the BigQuery window and we'll get started. Right. So this is our interface once you're on BigQuery, as opposed to your traditional databases that just have the concept of um, databases and schemas and tables. Here you have the concept of data sets and projects. So this is actually a project name, and we don't have any data set yet. But the good thing about BigQuery is that it provides something called public data sets. And public data sets simply public data sets will let you access and run queries on data that you didn't create. So that's one good thing with BigQuery, as opposed to your traditional DB where you can only work with your data. And if you need some data, you have to go out and source it yourself. With BigQuery, there are people who host data up, they make data publicly available. You will, of course, be charged by BigQuery for querying the data, but you won't be charged for storing the data. And that's an important consideration. Now, in BigQuery, this is the editor. This is where you write your queries, and this is where you get your responses. And what we're going to do today is we're going to look at an example of data that is collected on taxi trips. And then we're going to look at how to run machine learning on this data. And the key point here is that we're going to be doing all of this with SQL. So there's no Python or any other programming language, so to speak. Now, the first thing that I'm going to do is I have the query that queries a public data set. So remember, we don't have a data set here yet, but I have pasted a query from a public data set, and this is the data set that holds that public data set. This is it here. And I can hold on my command on Mac or control on Windows, and you see that this URL here changes, and you have a hand, and I can then click on it, and it will open up the actual table. This is the table. The window is not too large, so you can't see it properly. Not sure if I can do this. I wish it didn't. Let's do this. And what you can do is you can then inspect the table schema. You can see what fields you have and the types. And there's also a preview window where you can see what the data in there looks like. So you can see that this table has things like a pickup date time, a drop-off date time, passenger, and stuff. We'll also see the same thing when we run the query. Now, the key thing with BigQuery, if you're new to BigQuery, coming from a place like PostgreSQL or MySQL, is that you need to keep an eye on the size of the data that will get processed, because you have a free tier, but after that free tier, you start to pay for things. So this query will process 1.9 gig, sorry, 1.09 gig. But something more important here is that we're selecting not everything, but the pickup date time, and we're interested in the month of the pickup date time. So what's happening here is that you'll see the month and the number of trips in that month in the results set. So it's not all of the columns that you'll see. You're going to see aggregate data. And then the second thing here is that the table name itself has this suffix, which is 2015. It's one style of partitioning tables in BigQuery, such that if you want data from a particular period, you don't need to use a where clause. Instead, you just pick up only that table. And if we wanted all of the data, we would use a wildcard here in the table name. Okay, so the rest of it is standard SQL, and we can go ahead and run it. And you can see some information, some execution details at the bottom. And when it's done running, we have a result set. So we use this function timestamp trunc to truncate by month. And what you end up with is you still have the year, you still have the month, but it changes that date to just the first day of the month. So what you're going to get is the result is for the first day of every month, and you're going to have 12. Okay. Why do we have? Yeah. So you have 12 of them from January to December, and then you have the number of trips. Okay. Let's close this so that we have more space to work. Okay. So now we've got our data that we want to work with, and it's trip data. So basically, what we're looking at is how many trips took place every month of 2015, and we've got that. You can, of course, go in and analyze the data as much as you want, but let's look at this new query now. And here we are getting the hour of the day in which the trip happened. And then we're getting the average trip. So basically what we're saying is how much traffic is there on an hourly basis, or how long does it take to go somewhere based on the time of the day. And so if you think about this, it's really about how long would it take to get somewhere, depending on when you want to go to that place, right? And if you use something like Uber or Bolt, you start to get a sense of how they're able to estimate how much time it would take for a trip. Again, we're using the same table. Now we start to introduce conditions, right? So we want a situation in which the trip distance is greater than 0. We don't have enough time to go into why a trip distance might be negative. And we also want where the fair amount divided by the trip distance is between 2 and 10, and where the drop off time was after the pickup time, right? So we have a second query here, and we can run that, and that should give us some information about how slow traffic can be. And so 0 here is midnight, and we see that the speed starts to pick up after midnight and all the way until 5 a.m. And then the speed starts to drop from 6 a.m. all the way until 9 p.m. And then at 9 p.m., it starts to pick up and it repeats all the way until 5 a.m. again. Right. So when you're thinking about taxi cab and trips and things like that, what you really think about is the road conditions. So how many people are on the road? How quickly can you travel? That determines how much time it would take, and that determines the cost. So two things, distance and time determine the cost. There are some other factors like having tolling plazas on roads. So with some of this information, you try to get a sense of what the road conditions will be. So now we're going to create a machine learning model using SQL to predict the cost of a taxi trip. And this is within New York. So just think of it like, can we build the infrastructure that estimates pricing for an Uber or a Bolt? Now, what we're going to do is we're going to go look at some additional data that we have in the table. So there's quite a bit of data, and let's look at this new query. So first we create a common table expression. So if you've never seen it and you're seeing a with and an as, it's just a common table expression. So we're doing things like we want to be able to partition our data, because in machine learning, you always have a holdout set. So you want to be able to get a training data set and a validation data set. And then we also want to simplify the days of the week. And then in our query, what we're doing is we're going to take the amount that was paid for passing through any toll, as well as the amount that was paid for the trip itself. And we're going to call that the total fare. And then we want to take the day of the week as well and the hour of the day, because remember, speed varies based on the hour of the day. And then we want to take the pickup longitude and pickup latitude, because that tells you exactly where someone was picked up within a certain bound of error, and then also where the person was dropped off. So instead of a complicated situation in which you're thinking about street names and things like that, it's enough to think in terms of just an area. And then the final thing that we're going to consider is the number of passengers that were picked up on that trip. Okay. And then let's look at the data that comes out from this. I highlight something. Right. So with this, we then have some more information. So we've got our total fare, our day of week, hour of day, pick up longitude, pick up latitude, drop of longitude, drop of latitude, and passengers. So what we're going to try to do is train a machine learning model on this data. And recall again that we're not writing any Python. We're just going to go do SQL. So let's create a data set to store the model that we're going to create. So you can store tables, you can store views, you can store models. And so this data set I will call taxi and leave all of the defaults the way that they are. So now what we want to do is we want to create what's called a regression model. And that's because we're predicting the cost of a trip. So let's go full screen again. And now we've identified the data we want to work with. So let's look at what our new query looks like. So line 4 downwards is exactly the same as the last query that we worked with, which is it just creates so the query just creates the data that we're going to use. Now there's something else here that I should highlight in our where clause. So we've got this long function, which is it's a nested function, but basically I'll read it outwards. What we're doing is we're taking our pickup date time and we're converting it to a string. And then we're using something called farm fingerprint. And what farm fingerprint does is instead of using random to select data, which could potentially give you a result that is not reproducible, what we're doing here is we're using farm fingerprint. So farm fingerprint will make sure that your result set is always the same. So that's what we're using here. And then the absolute and the modulus just help us with filtering out the data. But basically what it means is that every time you run this query, you'll get exactly the same. And so what we're doing here is we're splitting into 1,000 different parts. Then at the top, we introduce 3 new lines of SQL that let us train this model. So the first one is create or replace, which is a standard thing in SQL. But instead of table, you have model here. And then this is just the data set in which the model will be stored. So remember, we just created the taxi data set, and then the taxi fare underscore model is the name of this model. The second line is just options. It's really second and third line are together. It's options, which is a function, and then we specify our model type as linear regression, and then we specify our labels, which is what we're trying to predict, as total fare, which is the column, which is this one here. And then we put an as, and then the rest of our standard SQL follows. So lines 1, 2, 3 are what you won't find in, say, MySQL or Microsoft SQL Server, but it's still SQL. You're not, you're not writing any Python or some other programming language. And that's it really. We're ready to train a model. We're ready to hit run here. And you have all of the execution details at the bottom. So we'll just give it a few more seconds. It's not a lot of data, and the model will train quickly. This is going to be what we'll call a baseline model. It's our first model. Typically, it won't be your last. You'll train that model and then you'll evaluate it. And then maybe make some adjustments, maybe collect more data, maybe engineer more features. But here it is, we've got a model. And we can go take a look at the model. We can say it's a linear regression model, and there's all sorts of details about it. We can see that this thing trained for one epoch or one epoch. So while you're not writing Python, you still need to have a sense of what's going on in the world of machine learning. So you need to know what a linear regression model is versus what a logistic regression model is. What's this L2 regularization, for instance? I'll skip over it. But you need to know those things. And you can go and look at the training details. Because it was just one iteration, there really isn't much to see there. But if you chose the table view, you could see what your training data loss is, and you can see what your evaluation data loss is, and you can see exactly how long it took. And when you go to evaluation, you can see all of the evaluation metrics. So there's a mean absolute error, a mean squared error, and all of those things, right? And so we can go back to our query window and move ahead. Now, while we have the query that trains this, we can also write a query to evaluate the model. So we've seen the evaluation metrics, but again, the data is the same, but right now, what we're using is params.eval. We use params.train to train the model. Here, we're going to use params.eval. So our query from line 4 down is the same. On line 2, we have a select. So it's not a create or replace now, it's a select. But what we're selecting is a function, the square root of the mean squared error as the root mean squared error from not a table now, but ml.evaluate. And then we have to specify that we're evaluating a model, and then we pass in again the data set and then the model name. The rest of the query we've already seen in the past. So just a few more SQL statements that we're dealing with here. And we can go ahead and run. And what it will do is it will take our validation data set, run it through the model, compare the predictions from the model against the actual cost of the taxi trip, and then it will compute a root mean square error for us. And recall that this is your baseline model. So what you want to do subsequently is train models where this root mean squared error gets lower. But that's it. We've trained a model. we've evaluated the model, and that's machine learning. Of course, you want to put that into production. Right. So to put this into production, we've created the model, we've evaluated the model. All we have to do is run select on the model, and that's it. Select all from ml.predict your model, and then the same query, but this time around, the data should be different. So this is how you would use the model continuously. Now, to put it in production, it depends on what you're doing. If you do batch predictions, then you can run this manually, and if you like, you can always export. You can export your results to CSV files, for instance. If you don't have too many, you can export to Google Sheets if you don't have a lot of data even. But you can also put this behind some sort of cloud function, and then you can actually call it from an app and pass data to it and get your predictions out. So it all depends on how you want to make use of this. But long and short of it is, you can, as you see, make predictions. Now this data is our validation data. So we can see what was predicted and we can see what the actual fare was. Of course, it's our first model, so our prediction isn't any good at all. It's way off the actual fare. But then this is where you can go in and start to engineer some data and train new models and try and get a better model out of it. And so let's see how we might do that in here now. So let's look at some details of this data that we're working with. So here, this is basically some summary statistics. And so what we see is number of trips, but we can see that there are some fares that are negative for some reason, and that shouldn't be. And then we can see some fares that just look outrageous, like what is a $503,000 taxi trip, right? But then the average is like $11, and then the standard deviation is 650. So what do we do with this information? We then try to filter. So we add a where clause. And so, first of all, our trip distance should be greater than 0. And we don't want a fare amount that is over $200, right? So what happens when we look at that? We then get that the lowest fare is $6, highest fare is $200, and the average fare is now almost $13. But standard deviation has gone down from 650 to 9.15. Okay, so that's a little bit of sanity, and that's one of the reasons why you run that's why you run analytics on data before you start to create ML models. So now let's look at some additional filters. And now we're filtering the pickup location and the drop-off location as well, right? Okay, so when we do that, everything still looks same, the average fare, the standard deviation. So things are looking good in there. And then we can go ahead and retrain our model with these new filters in place. So again, we have our create or replace model. We're creating a second model, so we call it model 2. And every other thing in here you're used to. So nothing new per se, just a bunch of new where clauses. And we can let it train the model. We probably need to give it 2 minutes to do this. And our model is ready. So we can go take a look at this model, this new model. And again, some of the data in there, still trained for one iteration. But now our training data loss is 26, and you can compare that to the loss from, where's our first model? Okay, I probably closed it, but this is less than what we had in the first model. And similar to what we did with the first model, we can evaluate this. Okay, sorry. If you even go to evaluation here, you can see things like the mean absolute error, the mean squared error, and everything here is actually less than what it was in the first model. So for comparison, this is our first model, and the numbers here are higher. Like this is 88, this is 5, this is 4. And when we look at this is 19, this is 2, this is 1. So yeah, it's less. That's all we can say. Okay, what are our queries? Okay, so we've trained the second model, and so we can go ahead and evaluate it and see what the evaluation metrics look like. Did I change this? Okay, so let's try to run the evaluation. And so we have our root mean square error now. And similar to the last one, we can actually just go ahead and start using the model. So that's it really with SQL and machine learning on BigQuery. It's called BQML. You can check out the docs. So if you just search for BigQuery machine learning, you'll go straight to the docs. You'll see the various models that are supported, various model types. Um, okay, so let's jump to the docs. And this is what it looks like. So it doesn't teach you SQL, but it tells you what sort of I mean how to create your models um, and the various model types. So let's try and get this camera out of the way. Um, yeah, so you've got everything here really. So just go to BigQuery machine learning, and you have all the info that you need to get started. So it's fine if you can't remember all the queries that you just saw, but it's properly documented, fully documented, and that's it. Okay, so I just need to do some cleanup and close out this. But yeah, please feel free to reach out with any questions if you have or any comments. So I will end the broadcast now. Thank you everyone for joining.